All right, so today we're going to be using this formula right here, the compound interest formula. You may have used this before, maybe not. And so it's kind of for both saving money and for borrowing money. So real life application here. And so here's the formula. It says A, which is the amount you have at the end, equals P, which is the amount at the beginning that you kind of either borrow or that you invest. And then we have 1 plus R is the interest rate. That's got to be a percent. N is the number of times compounded per year. So for N, if it says something like, I don't know, daily, if you do something daily, you would do it 365 times a year. If you did it monthly, that would be 12 times per year. And if you did it semi-annually, that means just every 6 months, so that is 2 times per year. If it is annually, it would be once a year. And then T is time in years. So we're just going to kind of see what we have here and see what happens. So number one, it says a sum of 100,000, or sorry, not 100,000, just 1,000 is invested. So that's my principal. That's how much I'm putting in. Our interest rate is going to be 1%. Now that's actually 0.01. So to change it to a decimal, you move the decimal twice. Find the amount in the account after 3 years. And so T we know is 3. If it is compounded monthly, so that means N is 12. Okay, so here it looks like we have everything on the right side of the equation. So A is the unknown. So I'm going to say A equals question mark. So we'll say A equals, let's see, we're going to put in 1,000, parentheses, 1 plus 0.01 to the power of 12 to the, 0.01 over 12 to the power of, and then you kind of need extra parentheses up here on most calculators, so I'm just going to throw those in there. And then this is to the power of 12 times 3, so it's n times t. So you can see that the n does show up twice there. After that, we're just typing this into the calculator, and so I type that in the calculator. Let me see what we get here. If you don't have your own calculator, you can use Decimos. Is really good at these, Decimos.com. All right, so that comes out to 1030.44. And we kind of always round this to the nearest penny because the bank will pay you pennies. And so what that's saying is for 3 years of your investment, you're going to get an extra $30. So that doesn't seem like a lot. But remember, this is money for kind of nothing. It's just having your money sit in the bank account. The bank is going to give you a little bit of money in interest. It's certainly not going to be a lot. It's not going to make you rich. But once again, money for nothing, so not too bad. Okay, so next one here, it says how much should be invested. So on this one, they're actually asking us for P. And it says that we want to end up with $500. So that's going to be our A value. It says T here is 2 years. And then we have an interest rate of 0.03. And then semi-annually means that N is 2. So in this one, the setup's going to be a little bit different because we know what the A is. So we know what this number out front is. So I'm going to say that's 500 out front. And then I'm going to leave P as a variable. And then in here, we're going to do 1 plus 0.03 over 2 to the power of, and this time I'm just going to multiply these numbers together. So it's n times t. So 2 times 2 I know is 4. So I just went ahead and multiplied those together. I could have done that on that last one and just called this 36 if I wanted to. Okay, so P is multiplying by this big thing over here. And so to solve this, I'm just going to divide that over to the other side. I know it's kind of multiplying by a lot, but it is multiplying. And so anytime we have something multiplying, we just divide it over. And I can just type that in the calculator just like that. We got to make sure we use the parentheses. So once again, type that in your calculator. The iPhone calculator is not great at these, so I might recommend, like I said, Decimos. So let's type it in and see what we get here. And I got that P equals 471.09. So there you go. So that's saying if we invest $471 and wait 2 years, we'll have $500. So we get an extra about $29. So once again, not going to make you rich. All right, next up here, it says you put $1,000 on a credit card that charges. So you put $1,000 on a credit card. So instead of saving his time, we're borrowing, but it's the same idea. So we're starting off with $1,000. And in this case, it says, how long will it take until you owe $2,000? So that's saying, I know the starting amount and the ending amount, but the question here is, what's the time? Now in this one, it says the credit card charges 21% interest. And so, let's see, R is 0.21. And if that sounds crazy, it's actually not. This is actually 21% is a very common interest rate. It could be even higher than that. It could get up to 30 on a credit card. So that's why, when you're saving money, it's not gonna change your life, the interest. But when you're borrowing money, especially on a credit card, that really is life-changing money. And so that's why you got to be really careful to pay off your credit card bill at the end of every month, because that means that if you don't, you're going to be getting charged this crazy interest, and you're gonna owe a lot more money. All right, so then it says also that it's compounded monthly, so n is 12. So I'm just going to set up here with everything. It looks like time is the one thing we don't know, and so I know that this is this is out here going to be 2,000 equals 1,000 times 1 plus 0.21 over 12 to the power of 12 times t. And so in this case, I see actually my variable is in the exponent, so I'm going to have to use logs. Before I use logs, though, I have to divide this front over here. So then I get 2 equals, let me give myself some more space here. 2 equals this 1 plus 0.21 over 12 to the power of 12t. So now I need to switch it into log form, and so I'm going to do a log. The base here is actually this whole thing. That's the base with this exponent, and so that is my base. So when I do this, I'm going to say log base 1 plus 0.21 over 12. So that is kind of an intense base there, but it is our base. Remember, it's got to get the new partner, so it's got to be 2 inside of the log equals 12t. So now remember, when we type this in the calculator, we always do it as log of the top one over log of the base. And so this is going to be how I type it into the calculator. And that equals 12t. So I am going to type that in the calculator now. You can, once again, use decimals for that. Log 2 divided by log of 1 plus 0.21 over 12. And so that's going to say that 12t equals 39.954. And so if I divide that by 12, then I'm going to get my final answer. And so t equals 3.3 years. Remember, time is always years in this, so when I figure out the time, it is coming out in years. All right, to finish off here, we're going to review some expanding and condensing of logs. Now, this one actually, we have this 3 that's outside of everything. What I would always do on that is send it in, and that multiplies by all the exponents. So it's actually going to turn into log base 6 of a to the 3rd over c to the 3rd and b to the 15th. Remember, if we have that base has multiple multiple exponents, they multiply together. And so now I can separate it out. Remember Mr. Berry's trick here of everything from the top is going to be in a positive log and the bottom is going to be in a negative log. So I'm going to have log base 6 of a to the 3rd minus log base 6 of c to the 3rd minus log base 6 of b to the 15th. And then our last step there is to move those exponents to the front and have them be coefficients. So I'll go over here inside of number 8 space. So I have 3 times log base 6 of a minus 3 times log base 6 of c minus 15 log base 6 of b. All right. Number 9, kind of just the reverse of that. So first I like to move these up to the exponents, and I don't like to rewrite that, so I'm just going to do it right here. Oops, that one didn't have one. Okay, and so then remember that I'm going to build a log here, and the base is going to stay the same, and I'll do a fraction. Everything from the numerator is going to go up here. or sorry, everything from a positive log is going to go in the numerator. The negative logs will go in the denominator. Now in this case, I actually have all positive logs. So that actually means I don't really need a denominator. And so I'm just going to rewrite this as a to the 5th, b to the 6th, and c. Since there's no denominator, I don't need to write it.